World War II sparked desperate innovation. Nazi Germany, facing defeat, created Vergeltungswaffen, revenge weapons. The V-1 flying bomb and V-2 rocket aimed to terrify the Allies, but the wildest was the V-3 cannon, a giant gun meant to strike distant cities. Yet ambition alone couldn't win the war. The V-3 faced impossible hurdles from the start. The main target for the V-3 was London. Nazi leaders believed attacking Britain's capital could break morale. Their plan: bombard London from occupied France, firing shells over 100 miles. If it worked, silent, unstoppable shells would rain destruction on the city. London was not just a city, it was a symbol. Most big guns could be moved or aimed at different targets, but not the V-3. It was designed as a fixed installation, built into the chalk hills of northern France at a place called Mimoyekes. Once aimed at London, it could not be turned. The V-3 was supposed to be used for continuous shelling. The idea was to fire hundreds of rounds each day, creating a non-stop rain of shells. This was very different from other superweapons, like the V-2 rocket, which were fired one at a time from mobile launchers. To make this dream possible, the Nazis planned to build a fortress around the gun. Deep tunnels and strong walls would protect it from bombs and spies. Loading and firing would be done by crews working around the clock. But this fixed position was a double-edged sword. It made the V-3 powerful but also easy to find and destroy, as history would soon show. The real magic of the V-3 was its firing technology. Instead of one big explosion, it used many smaller ones. This was called multi-charge or staged propulsion. Along the long barrel were side chambers filled with extra gunpowder charges. As the shell traveled down the barrel, it passed these side chambers. Each one fired in turn, giving the shell another burst of speed. This made the shell go much faster and farther than in any normal gun. This system was revolutionary. In theory, it could let the gun fire shells much farther than ever before. It also meant less stress on the barrel, since the energy was spread out over many explosions instead of one. However, making this work was very hard. The timing had to be perfect. If even one charge fired too early or too late, the shell could slow down or blow up the gun entirely. Constructing the V-3's barrel was a nightmare. It was supposed to be over 400 feet long, about the length of a city block. Each barrel pointed at a fixed angle, buried deep underground to hide it from bombers. Steel was in short supply by the time the V-3 was being built. Finding enough strong metal to make these massive tubes was honestly really difficult. Each barrel had to be straight and smooth inside so the shell would not get stuck or wobble. Making the barrel strong enough was only part of the problem. The extra side chambers for the multi-charge system made the design even more complex. Every joint had to be sealed carefully so no gas would leak out and no explosion would go the wrong way. And to add to the problems, the barrels could not be moved once they were installed. Any mistake in building or aiming them was almost impossible to fix. Ordinary artillery shells would not work for the V-3. It needed special long, thin shells, almost like giant bullets. These shells had to be strong enough to survive all the explosions as they shot down the barrel at high speed. Each shell was about 3 meters long and very narrow for its length. Inside was a powerful explosive charge and a simple fuse. The shell's shape was chosen for maximum speed and range. It had to fly over 100 miles to reach London. Designing these shells was a major challenge. They needed to be light but tough, able to spin for accuracy without breaking apart. Tests showed many shells broke up or wobbled in flight, making them wildly inaccurate. Even with the best designs, the shells were much less powerful than a bomb or a V-2 warhead. The Nazis hoped that the sheer number of shells would make up for this weakness. Firing the V-3 was not just about pulling a trigger. It was a complex sequence that had to be timed to the millisecond. First, the main charge at the back of the barrel exploded, pushing the shell forward. As the shell sped down the barrel, it passed a series of side chambers. Each chamber contained an extra gunpowder charge. These had to explode at exactly the right moment, just as the shell was passing by. Too early, and the shell could slow down or be pushed off course. Too late, and the charge would explode behind the shell, wasting its power. The entire process was controlled by electric circuits and sensors. This level of precision was cutting edge for the 1940s. If anything went wrong, a misfire, a jam, or a faulty circuit, the consequences could be disastrous. In practice, this made the V3 much more likely to fail than simpler weapons. The need for perfect timing was its greatest weakness, as well as its greatest innovation. To protect the V3, the Nazis built the gun into a fortress at Mimoyeques. The site was carved out of solid chalk and limestone, far underground. It contained a maze of tunnels, rooms for ammunition, living quarters, and these massive barrel shafts. The main fortress was actually designed to hold several V3 barrels, each one aimed directly at London. Rail lines were dug into the tunnels to bring in shells and supplies. Thousands of forced laborers were used to dig and build the site under just terrible conditions. Above ground, the gun sites were disguised with earth and camouflage. Anti-aircraft guns tried to protect the site from Allied planes. The Nazis hoped the fortress would be bomb-proof and, well, pretty much unstoppable. But the sheer scale of the fortress made it hard to hide. Allied spies and pilots soon discovered what was happening at Mimoyeques, setting the stage for disaster. Operating the V3 was, honestly, incredibly complex. It needed a large crew of trained gunners, engineers, and maintenance workers. They had to load shells, check each side chamber, and make sure the electric firing system was actually ready. The loading process was slow and dangerous. Each shell, weighing about 140 kilograms, had to be moved into place on rails or trolleys. Explosive charges needed to be inserted into every side chamber along the barrel, all while underground and under threat of bombing. Keeping the gun firing continuously meant a really tight schedule. Every mistake, like a stuck shell or a misfired charge, could bring everything to a halt. Supplies of shells, charges, and spare parts had to be hauled in constantly, often under fire. Working conditions were just terrible. The noise, smoke, and vibration were overwhelming. Most gunners had to wear ear protection and masks, and the risk of accidents was always high. For all its ambition, the V3 had some serious flaws. Its biggest weakness was that it was fixed in one spot. Once the Allies found Mimoyeques, they could target it pretty easily. If the gun was damaged, there was just no way to move or hide it. The technology was also very complex. The multi-charge system needed perfect timing, which was honestly tough to achieve in wartime conditions. Even small errors could destroy the barrel or make shells go off course. Maintenance was, well, difficult. The gun was buried underground, with little room to work. If a shell jammed or a chamber failed, repairs could take hours or days, if they could be done at all. Finally, the gun was vulnerable to bombing. Even the deep tunnels couldn't protect it from the biggest Allied bombs. The Allies quickly learned about the V3 project. In 1944, they launched massive bombing raids on Mimoyeques. New tallboy bombs, huge, deep-penetrating explosives, were dropped on the site. These bombs shattered tunnels, crushed barrels, and killed many workers. The bombing made it impossible to finish the V3. The barrels were smashed or buried in rubble. The fortress was filled with debris and water. Even Hitler had to admit defeat. The site was abandoned before it could ever fire at London. The V3 was finished, without firing a single shot in anger. The V3 cannon stands as a symbol of both human ambition and its limits. It was one of the boldest weapons ever imagined, but it was also deeply flawed. The technology was ahead of its time, but not practical for real war. The dream of bombarding London from France never came true. The gun's complexity and vulnerability made it a dead end, not a game changer. The Allies' quick action showed that even the wildest superweapons could be stopped by determination and teamwork. Today, the ruins of Mimoyeques remind us of the dangers of unchecked ambition. The V3 is a warning. Engineering can achieve amazing things, but only if it is matched by good sense and practical planning. In the end, the supergun was a fascinating failure. a lesson from history about the real limits of innovation in war.